Aerospace Systems Engineering Training. Aerospace Systems Engineering Training covers the essentials of systems engineering and their applications in aerospace systems, stressing business and military systems. We will furnish you with a common sense learning, everything being equal, specialized and administrative, incorporated into systems engineering as utilized as a part of aerospace systems of variable intricacy. This hands-on training will center around the testing parts and systems advancement, including prerequisites definition, mix, circulation of necessities, chance administration, confirmation and approval. We additionally will talk about the procedures and techniques utilized on business systems, DoD, NATO and NASA programs. Learn about systems engineering practices, terms and methods, system life cycles used by INCOSE, DoD and NASA, requirements generation, trade studies, architectural practices, functional allocation, verification, validation methods, requirements determination, risk management, evaluating specialty engineering contributions, importance of integrated product and process teams. Aerospace Systems Engineering Training is delivered in the form of hands-on training that includes labs, group activities, real-world case studies, and hands-on workshops. Audience: a 3-day course designed for systems engineers, aerospace engineers, space program managers, military avionic program managers, space, military, and commercial product managers. Training objectives: understand the fundamentals of systems engineering, describe avionic and aircraft systems, define aerospace systems engineering processes, describe the aerospace associated programs life cycle process, identify aerospace systems components, identify and provide systems requirements and management, design the aerospace system, integrate their aerospace specialty into systems engineering, model aerospace system architecture, apply verification and validation techniques, apply the models and methods fit aerospace systems, manage technical data, manage and mitigate technical risks, conducting cross-cutting techniques, manage and support required logistics, understand data acquisition and control systems. Course outline: overview of aerospace systems engineering, system life cycle process, aerospace systems engineering management concerns, systems assessment and modeling concerns in aerospace, integrating aerospace engineering into the systems engineering process, functional assessment methods, functional analysis, TONEX case study sample, International Space Station, ISS. Overview of aerospace systems engineering, systems engineering, systems engineering components, system of systems engineering objectives, systems engineering discipline, aerospace systems, NASA space systems, DoD system of systems, SOS, system life cycle process, researching the V diagram, the project life cycle process flow, preliminary analysis, definition, development, operations and maintenance, the budget cycle, aerospace systems engineering management concerns, coordinating balanced goals, work products, and organizations, the Aerospace Systems Engineering Management Plan, SEMP, the Aerospace SEMP Impact, the Aerospace SEMP Content, the Aerospace SEMP Development, the Work Breakdown Structure, WBS, versus Product Breakdown Structure, PWBS, WBS and PBS roles, WBS and PBS development tools, common mistakes of WBS and PBS, scheduling and scheduling impact, system schedule info and visual styles, setting up a system schedule, reporting methods, resource leveling, budgeting and resource management, risk management, various types of risks, risk determination methods, risk assessment methods, risk reduction methods, configuration management strategies and more. Systems assessment and modeling concerns in aerospace. The trade study development. Regulating the trade study. Models and tools. Selecting the selection rule. Defining and modeling the budget. Life cycle expenses and other expenses evaluation. Monitoring life cycle costs. Cost approximation. Defining and modeling the effectiveness. Measuring the system effectiveness methods. NASA system effectiveness evaluation. Accessibility and logistics supportability modeling. Probabilistic management of cost and effectiveness. Origins of uncertainty in models. Modeling methods for managing uncertainty. Integrating aerospace engineering into the systems engineering process. Aerospace engineering role. Reliability. Role of the reliability. Building consistent space-based systems. Reliability assessment tools and methods. Quality assurance. Role of the quality assurance engineer. Quality assurance tools and methods. Maintainability. Responsibility of the maintainability engineer. The system maintenance notion and maintenance plan. Designing maintainable space-based systems. Maintainability evaluation tools and methods. The Avionic Integrated Logistics Support, ILS. ILS components. Planning for ILS. ILS tools and methods. Continuous attainment and life cycle support. Verification. Verification process and verification planning. Qualification verification and more. Functional assessment methods. Functional methods. N2 diagrams. Timeline analysis. Functional analysis. Boeing B777, fly-by-wire flight control systems. Electrical flight control systems. Navigation and tracking systems. Flight management systems. Synthetic vision. Communication systems. Satellite systems. Sensor systems. TONEX case study sample, International Space Station, ISS. Some background. ISS systems engineering elements. ISS systems engineering principles. ISS systems engineering accomplishments. ISS systems engineering challenges and failures. ISS systems engineering configuration management. ISS systems engineering quality assurance and maintenance. Aerospace Systems Engineering Training Course. Price, $2,499. Length, 3 days. Call TONEX Expert 1-972-665-9786. Visit TONEX website below www.tonex.com web link.